Okay, so that we just graphed tangent. All right, now let's do the same activity with cotangent. Okay, so notice that at 0 and at pi, cotangent's undefined, right? So at 0, there's gonna be a asymptote, a vertical asymptote, right? At 0. And at pi, there's gonna be a vertical asymptote as well. Okay. And if pi, negative pi as well, right, is going to be a vertical asymptote if I go negative direction. So 1, 2, 3, 4, negative pi. There's my vertical asymptote. Okay. And again, at 2 pi and at negative 2 pi, there's a vertical asymptote. Well, that's positive. 1, 2, 3, 4 at negative 2 pi, right? Okay. So here's all my vertical asymptotes. Just like tangent, halfway between is going to be my zeros. So from 0 to pi, that's going to be pi over 2. That's a 0. Negative pi over 2, that's a 0. Negative 3 pi over 2, that's a 0. And negative or positive 3 pi over 2, that's a 0. Okay. Now let's just focus on one curve. All right. Because the curves are going to just be the same anyhow. Right. So if I focus on one set of asymptotes and I get the general direction, I should be good. Right. So from 0 to pi, I'm going to focus there. So from pi over 4, cotangent is 1. So at pi over 4, which is halfway between 0 and pi over 2, pi over 4, cotangent is 1. And then at 3 pi over 4, cotangent is negative 1, right? And this is 3 pi over 4, cotangent is going to be negative 1. So I have something that looks like this, right? Notice that they're kind of like the mirror image. Yeah, the flip version of tangent on how it looks like. So here, halfway between is 1. Here, halfway between is negative 1. So I have these guys just going up and down. 1, negative 1, going up, coming down. 1, negative 1, going on up, coming on down. Okay. Cool. Questions? And from here, class, all we're going to do with tangent and cotangent is just vertically stretch them, shift them left and right, and up and down. Okay. So when we vertically stretch them, these ones and negative ones just become stretched out. Okay. That's what the vertical stretch, that's what your A value for your sine and cosine function does. Okay, that's the transformation there. If you move it left and right, every asymptote moves left and right along with the curve. Okay. If you move it up and down, only the curves move up and down. Okay. So let's try that out a little bit with y equals tangent of 3 or 3 tangent of x. Okay. So I know this 3, right? All I'm doing is moving or vertical stretch by a factor of 3, right? So all I'm doing, class, is I am gonna draw out the parent function, okay? Which here is my vertical asymptote. Here is my vertical asymptote. In between is 0. In between here is 1. In between here is -1. So here is my parent function, right? So in this, that's just tangent of x. Okay? You guys see that on how I did that? So if the vertical stretch by a factor of 3, all I'm going to do is just multiply -1 and +1 by 3. So 2, 1, 2, 3. So it jumps. This point jumps to here. This point jumps down here. The 0 stays the same. So it vertically stretched. You guys see the stretchiness of that line? Yeah, compared to the original. Okay? That's all it is, class. All right? Yes. Okay? Questions? No? Let's do this one here. Okay, I want to change this into cotangent. Okay, just so that we could practice both. Y equals 2 cotangent of x minus pi plus 3. So here is a vertical stretch by a factor of 2. This negative pi, we're going to move the whole thing to the left pi units. It's not to the left, it's to the right pi units. And this 3, we're going to move it up 3 units. Okay? So that's what we're going to do. So let's do that. So it's cotangent. So my vertical asymptotes are at 0 and at pi. Okay? I know halfway between 0 and pi is pi over 2, and that's 0. That's going to be 1. That's going to be -1. I know halfway between is going to be 1. And that's -1, right? Oops, sorry. I didn't move the picture up. Okay? All right. So that is my parent function. I'm not gonna draw the curves because then soon enough it's gonna look super duper messy. Okay. In red, I'm gonna vertically stretch this by a factor of 2. Okay. So what it means is that 0 is gonna stay at 0. That 1 is gonna be at 2. This -1 is gonna be at -2, right? Because 1 times 2 is 2. -1 times 2 is -2. Okay. So here, I'm gonna draw this curve. Is my curve for now, right? If I move this pi units over to the left or to the right, yeah, notice that this 0 asymptote just becomes this, right? At pi. This pi asymptote will now become 2 pi. Okay? This 0 point will become halfway between 0 and from this 0 to pi is 1 unit and it's going to go up to 2. This one's going to be at -2. Right? Does that make sense? Yeah. And here is my other asymptote. Right? So that this point is negative or positive 3 pi over 2. This point would be 5 pi over 2 or over 4. This is 7 pi over 4. How did I get that? Every unit is pi over 4. Okay? So 1 pi, 2 pi, 3 pi, 4 pi over 4, and then 5 pi over 4, 6 pi over 4, and then 7 pi over 4. Okay, so if you guys are ever confused about labeling them, yeah, just go step by step. Okay? And then from here, this curve or these points is going to go up 3 units. Okay? So up 3 units is just essentially 2, 3, 4, 5. This 2 is going to be now at 5. This 0 is now going to be at 2. This -2 is going to be 1, 2, 3 at 1. No. Oh, this 0 actually is going up 3, right? So it's not that. Okay? It is going to be at 1. So now my curve is going to look like this. Okay? Where the vertical asymptotes, when you go up or down, it's a straight line, right? Lines never end. So when you go up or down, they're exactly the same. Anyhow. Okay? That is the lesson for today, class. I want you to practice this via our Google Classroom assignment. And I will see you on the next one.